Hello, my name is Lan Pham. Today I'm going to talk about my final project, solar tracker. I'll give a little bit background on the solar trackers. So it can maximize the angle of the incoming sunlight to the photovoltaic panel. By doing this, the sunlight will increase the amount of the energy produced from the photovoltaic panel. In general, solar tracker provides more energy generation and efficiency to the photovoltaic panel. So the summary of my project is solar tracker will provide more energy generation and efficiency to the photovoltaic panel. And to understand more of the solar tracker, the goal of this project is to design and mimic a solar tracker. The final project is to have photoelectric sensor that will move towards the light source via servos. And this is the block diagram. The program starts by initializing the user parameters, input and output signals. After that, it enters a while loop. First, it calculates if there is a difference. If there is no difference, it lights up the LED light. Finally, it goes back into the beginning of the loop. If there is the difference, the servo will rotate and turn off the LED light. Afterwards, it will jump back to the beginning of the loop. These are the circuits that I'm learning throughout my research, which is green LED circuit. I have the diagram here, the servo circuit, and the photoresistor circuit. And at the end, I'm going to put all this circuit together and make my final project. The equipment I use for this one is this list, and some of them are like parallax, propeller, the photoresistors, servos, and etc. The procedure goes as first I initial the research and get the scope of the work approval. Then I gather the equipment and I create mini labs of the bigger project to better understanding and to dividing the workload. I look for references and helpful tips online from previous labs, and I design a miniature prototype. The most important part of the code is this equation, which gives a value in the range of 100 and -100 and 100, and I will compare this number value with the initial set point, and when this number is greater than that initial set point, then it will move the servo. This is all the references I use for my project. The end. Now I'm gonna demo my project and show how it works. So here are the project. I have two servo here. This is control the XY plane, and this is cover the Z plane. And here I also have 4 photoresistors in parallel. And this is the LED light. It will shine when my servo stop, and basically it's telling me that my machine is stopped where it received the most sunlight or the most light. So I'm gonna turn this off and using my light. So when I shine this, you can see how it moving towards the light, and you see that the LED light light up. It means that it reached the point where it received the most light. Yes, that's how it goes for my project.